moving on to chapter 2.7, the last portion of chapter 2, sketching the graphs of quadratic functions. So some things to note when it comes to sketching graphs. First of all, you must remember to label your axis. Secondly, your scale should be correct. What I mean is, for this chapter, usually they won't give you the scale, they won't specify the scale for you. So you have to decide whether do you need the positive portion of your y-axis or the negative portion of your x-axis, things like that. So that at the end of the day, your graph can take up at least 2/3 of the graph paper. Then next would be your y-intercept and your x-intercept. X-intercept, depending on the graph, there may or may not be x-intercept, okay, or there may be one or two x-intercept. Turning point and label graph. So for the turning point, because the keyword here is sketch, so by sketch, it means that you shouldn't be plotting or you shouldn't be filling in table to find your turning point. This is not plotting, it is sketching. So given the equation, you should be able to deduce turning points from the equation. And lastly, to label your graph. So this is the first type of equation that may be given to you. And this is actually the completed the square form. So when it comes to completed the square form, how should you approach this question? So this is a completed square form. Okay, I think my writing pad really not the best brand. So try it 23, sketch the graph of this. I'm just going to use this question to go through how to do this. My first step would always be find turning point. That's the whole purpose of completed square form. You should be able to see the turning point right away. What I mean by that is, look at this question. The turning point should be negative h and k. So where is your h? This -2 is your h, and this is your k. So whatever it is, you just put a negative in front first, and then you put in your h. Your h is -2, and your k is 3. So this is your turning point. Let's make it look neater. -2 will be 2, and k is 3. Okay, so whatever your h is, your h can be positive. So for example, if the question is x plus 2 square minus 3, then your turning point would be negative, whatever the h is 2, and your k is just as it is, -3. Then this is your turning point, right? So for this question, it is -2, and you put a negative in front, it becomes +2. And the k is just as it is, so it's 3. So this is my turning point. So in my graph, okay, never mind. So in my graph, I should have x is at 2 and y is at 3. Okay, just remember to label your origin. That's equally important. Maybe I forgot to include my previous slide. So this is your turning point. X is 2 and y is 3. Next, decide whether your graph is a smile or frown. So you look at this question. This is x minus 2 squared. If I expand this bracket, my x is just x squared. It's a positive x squared, so it's going to be a smile. So it's going to be a smile. Okay. Of course, you can draw nicer on graph paper lah. Part 3. The third part will be y-intercept. So if you solve or if you approach this question in this order, you shouldn't have any problem. So your y-intercept, my eraser. Okay, so the third part would be your y-intercept. When it comes to y-intercept just means that x equals to 0. So where is your x equals to 0? Your equation, sub in x equals to 0. And what you have is, this is 4 plus 3, 7. So I know that my graph is going to look like that. It has to be symmetrical, by the way. So let's label this is 2, 3. and it cuts at 7. Of course, this is not drawn to scale for now, but just remember to label all the intercept, okay? And question 4, my x-intercept. So there are no x-intercept in this case because there is no way your graph is going to go down. So this is your final version, and label the graph that you have just sketched. Remember, this chapter is about sketching, okay, which is different from plot. Plot means you got to plot a few points and join up the points, but this case it is sketch. So it should be like, okay, you mark in your turning point, you mark in your y-intercept, and if there is x-intercept, you mark it in, and then those are the points and you just join it up. That's a quick sketch. Okay, and you're done. For some of you who may still be confused as to how to identify turning points, I think I'm going to introduce another approach to understand how to sketch this kind of completed the square form equation. Let's start with this. Y equals to x squared. By now we all know how y equals to x squared should look like. It should be a smile that cuts through nicely at the origin. So this is my y equals to x squared. And then the next step I'm going to do is, if there's a plus 3, this is what I call a translation. So your graph will be translated upwards because y, you add 3 more to your y value. So now your y value should increase by 3. Okay, not very nice, but okay, you get the idea. So moving upwards by 3, this is my y equals to x squared plus 3 graph. And then now I'm going to translate my x. So everything remains the same except now I replace x with x minus 2. Now this is slightly counterintuitive, but when I change x, okay, to x minus 2, my x will move forward. So over here, this becomes still at 3, and my y is still at 3. Now my x moved forward 2 times, so my x is at 2. So this is a translation, again with this translation method. So we start with y equals to negative x squared. Then this is how my graph should look like. This is the most basic form, right? Okay, please pardon the ugliness. Then after that, my negative x squared remains. It's just now my y changed to, I'm going to shift it down by 3 units. That's why there's a negative 3, yeah? So I shift down by 3 units. Okay, and this is at negative 3. The next step, look at this. My x has been replaced by x plus 2. Counterintuitively, if my x changed to x plus 2, I should move backwards by 2 units. So at this point, my y, of course, is still at negative 3, and my x is now at negative 2. Okay, so do you see that my turning point is here? So if by the formula that you are taught, and you know that my x is, given this equation, I can immediately tell that, okay, my turning point is 2 and 3. I hope this gives some form of explanation as to what happens to your graph because of all this translation. And over here, by looking at the graph, you should know that it should be negative h, because this is your h, right? And this is your k. So negative h, which is negative 2, and whatever your k is remains. So this is your turning point. And therefore, see, they tally. So this is a translation that happens to your graph that gives you the turning point. Of course, this is like behind the scene work. I hope that gives you a little bit more insight to what happens to your graph. But during exam, you don't have the time to do this translation. You should just look at the graph and immediately deduce your turning point.